This video is on catalysis. We'll be using the notes that are entitled Catalysis. Okay, so this should be a fairly short video, and obviously it's about what a catalyst is, which we've already discussed. So a catalyst is defined as a substance that increases the speed of a reaction by lowering the activation energy. And an important point to make is that a catalyst is present at the beginning of the reaction. Okay, it's always there when the reaction starts. So there are technically two types of catalysts, and that is a homogeneous catalyst and then a heterogeneous catalyst. So as you are well aware, the prefix homo means the same, and so a homogeneous catalyst is defined as a catalyst that's in the same state of matter as the reactants. Okay, so if your reactants were both gases and then you had a catalyst that was also a gas, that catalyst would be referred to as a homogeneous catalyst because it's also a gas. Okay, and so same state of matter of the reactants is what we're looking at when we're talking about whether a catalyst is homogeneous or heterogeneous. Okay, so I have a quick example, but I'm going to erase my my board here. Okay, so you might want to write this. So there's a problem I pulled from the book. It says oxidation of SO2 to SO3 is catalyzed by the presence of NO2. And it tells us it's a two-step reaction, and it looks like this. Okay, so it's a two-step reaction here in this case, and yeah. All right, so we could write an overall reaction. I just noticed something. Hold on. Oh, okay, so I would need to, in this case, so my ultimate reaction, I probably should have told you this, is we're just looking for the conversion of SO2 with O2 to SO3. And so I would need to double my first reaction. So that then I can cancel out a few things. So the NO2s would cancel, the NOs would cancel, leaving me with two SO2s and two SO3s, and then this would be my reaction. Okay. So in this case, they told us that NO2 was the catalyst, right? Look, notice it's there at the beginning. Okay, and in this case, it would be referred to as a homogeneous catalyst because it's also a gas. Now, NO2 is a catalyst, okay, but NO is an intermediate. So be very careful about the difference between a catalyst and an intermediate. So an intermediate is created and then used while a catalyst is present at the beginning. Okay, it's super important to know the difference between the two. And of course, we know that that a catalyst works by lowering the activation energy. So if we had a reaction that looked like this, it's obviously just a one-step reaction, and we added a catalyst, it would do something like this. Okay, and that's the catalyzed reaction. Notice the delta E or delta H, right, remains unchanged with the addition of a catalyst. Super important. Okay, so on the next page, as you might have guessed, if homogeneous catalysis is the same state of matter, then there's a heterogeneous catalysis, which is where the catalyst is in a different state of matter compared to the reactants. Okay. So for example, sometimes it's worth talking about this idea. So maybe we have this reaction. It's going to be an all-gas reaction. And this reaction is pretty slow. So to speed this reaction up, the person performing this reaction might be interested in adding a catalyst in. And in this reaction, this reaction can be catalyzed by a couple different metals, one of them being platinum. And so sometimes you'll see it written like this, kind of above the arrow, and that is showing you that that's a catalyst. And so that's something that's worth knowing, that sometimes the catalyst is written above the arrow, okay? And in this case, it's a solid, so it's a heterogeneous catalyst because my reactants are gases. And that's all there is to this. There's a, practice question underneath. So we'll do that together, and then that will be it. It's very easy, a very easy discussion on catalysis. So the practice question says, NO catalyzes the decomposition of NO2, possibly by the following mechanism. So step 1, and then okay, so then I have a couple questions. A, what is the chemical equation for the overall reaction? So I would need to cancel some things out. Let's see, they told me that NO is a catalyst, so I know it's gonna cancel. So I'm gonna need to multiply this top equation by 2 so that I can cancel that NO. So this is gone, the 2 NO2s are gone, and it looks like that my reaction would be 2 N2Os making 2 N2s plus O2. It should be balanced, of course it is. So there's my overall reaction, that's part A. Part B says, why is NO considered a catalyst and not an intermediate? And so this is what we just talked about, that NO is present at the start of the reaction, and that is the criteria for a catalyst and not an intermediate. Remember, an intermediate is produced and then consumed. So it's not asked here, but is there an intermediate in this reaction? Yes, and the intermediate is NO2, because in the first step, the NO2 was produced, and in the second step, it was consumed. So that's the difference between an intermediate and a catalyst, and it's important for you to know the difference.